Okay, am I audible?
Yes, sir.
Okay, thank you. And the screen is also visible, no?
Yes,
My
sir.
screen
Right.
is visible. Okay, thank you. So now I will restart the today class, and today I kept most of the questions. So it look like very few people are coming in the meeting. Moreover, I observed that many people are looking this video on YouTube. And additionally, I want to mention over here, I have some throat infection. So I feel little bit difficulty in speaking. I feeling pain in my throat. So I will carry forward this class with a small break. Maybe this class maybe little bit small duration, but the content and the PDF document is already prepared by me. Will be shared with you. And if I feel better in the uploaded YouTube videos, I may keep the extra content by recording in intermittent time intervals, so that that will be helpful for you. So I will be thankful if you consider my situation. And I have observed that many few people are coming. And in the last class, I observed that attendance is list. I don't know why, but even you, Rian, I observed that in all of the lectures you have joined, but in the last lecture you are also not there. So I don't know, maybe some network issue, or maybe the link will be not shared with all of you. I don't know, but I have observed this thing.
No,
So
sir.
no problem.
It's a sessional was a start last week. That's why I'm not joined.
Sorry, I don't get you.
यूनिवर्सिटी सेशनल स्टार्ट हो गए थे जिस वजह से मैं ज्वाइन नहीं
Oh,
हो
okay,
पाया.
okay. No, that's not the problem. That's not the problem. It's okay for me. But I have observed that in the last class, very few people are there. In today class also, it's not that much attendance. In otherwise, I observed almost 17-20 students are coming up, but that's not the issue. So I feel that the lectures will be helpful, but I think as I feel too much pain while speaking as well. So it will be okay now if I kept this class small. Maybe I will end it by 4:30 or 4:45.
Yes, 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 sir. Yes, sir.
And maybe in 15 minutes I will take 15 to 20 minutes, or maybe at the interval of 30 minutes I will take small break, because I'm not very much comfortable in speaking today. Okay, so let me start now, because I don't think so other people are coming up. So if they will come, they will look after over here. Okay, so let me start. Okay, so now I'm starting the today class. Good afternoon, everyone. My name is Sumit Kumar. I am PhD research scholar at IIT Islamabad. This is the ninth class of soil mechanics geotechnical engineering coursework, and today we are going to discuss the several questions related to compressibility, in which we discuss various type of problem. I have specifically picked the questions from the previous year GATE examinations. Um, Mostly we are going to cover those questions only. Additionally, briefly we discussed the concept, but that not the point of concern, because in the last class also we have discussed that, and I am hopeful that if you have attended the lecture of the sir, you came across those things. Additionally, I want to mention over here that this class will run for 2 hours, and if due to certain reason my network get disconnected, so please be remain in the meeting. I will rejoin, and the class will start from there only. And as you have observed, this is the ninth class, and this coursework run up to 12 weeks. So 3 more weeks to go. I am hopeful that this coursework will help you in some way or the other. Specifically, I want to mention in starting that please try to solve questions related to the subject that will be that will be helpful in better understanding. In other things, I have discussed the topic of the shear strength over there. We have discussed about the several tests like direct shear test, triaxial test, Venn shear test, and many more. I have suggested that if you are the undergraduate student, you must try to perform it in lab. If some apparatus is missing, or maybe sometimes some equipments are not in the working condition, so you can also look after the NCTEL videos are there, which is the subsidiary of NPTEL only, and they will also explain step by step. And if the equipments are there, try to perform, because the theoretical concept is okay, but when you go to work in the field, that practical consideration will be very much helpful. Okay, so now first of all, in today's class, what we are going to discuss is about the compressibility. In compressibility, some terms are important. Let me write also. Okay, so over here you see it is mentioned that T equal to pi f4 into percentage U by 100 square. If you remember, what is this percentage U? Okay, so as I remember, we have discussed this in the previous class, but just for understanding that very less people are there, so I will explain this again, that we have to calculate the settlement. That is the delta H is the settlement in a specific time interval. So we have delta H by H, or you can say um, delta H by delta H into 100. This is percentage. Now the question arises, what is the small delta H and what is the capital delta H? So small delta H is the settlement at a specific time interval. Suppose a specific clay layer, which is rested below the sand layer, gets settled up to the total settlement maybe takes place in 10 years or maybe 15 years, and in that duration of time the total settlement takes place, may consider 80 mm, 90 mm, whatever. Suppose it is 65 mm. So, in 1 year time, there must be some settlement that might be 10 mm or 12 mm. So that 10 or 12 mm is the small delta H, and capital delta H is the total settlement. Suppose that is 65 mm in the case of a specific clay which is rested below the sand layer. When once we move to the question, the discussion get better and your understanding also get developed. So over here we have calculated the TB or T, that is equal to pi of 4 into percentage U by 100 square, and that percentage U is nothing but small delta H upon capital delta H. Okay. Okay. Um, Now over here you can see there are two relations has been given for T. One is T equal to pi of 4 into percentage by 100 square, and another is 1.781 minus 0.983 into log 100 minus percentage. I have explained you what is the percentage over here, but there is another thing in your mind, that when we use the first correlation and when the second. So the first correlation is used when U value lie below or equal to 60%, while when its percentage U become greater than 60 to 100%. So in that case, you use the certain correlation as t equal to 1.781 minus 0.9332 into 100 minus percentage. But again, over here, some things you need to remember. That is, what is the value of TV when the value is T or TV, whatever you say, is 60%, because you need not to calculate every time that whether the percentage is greater than 60% or less than 60%. So T value is 0.287 when you calculate pi by 4. When you calculate pi by 4 into percentage u is 60, 60 upon 100 square or whatever it is. So you get the value as 0.287, right? So in this manner you have calculated the value of TB. Subsequently, when the TB value is greater than 60, you use the correlation which is mentioned below, and you could calculate the value of TB for those cases. I will suggest you that later, once the lecture get over, you try this by yourself using the calculators, and you will get the correct picture of the thing which we are discussing over here. Now, when we are talking about the compressibility, over here it is mentioned that if the soil above and below the consolidating layer are pervious, the water under pressure in the layer will travel either upward or downward. This case is known as two-way drainage, and the length of drainage path, that is the maximum length that water practical particle needs to travel for dissipating pore pressure from consolidation layer equal to thickness of layer upon 2. Now understand this. Let me draw uh, some shape over here. Suppose over here you can see the figure that three layers are there, right? In which the second layer, suppose this layer is clay, which is present between the two layer, in which the upper layer is pervious layer and pervious means permeable, and this is impermeable. So if it is a pervious layer, then it's might be sand, but if it's a impermeable layer, it is clay, silt. So over here, when the load is applied, when the pressure is applied, when the load is applied in the downward direction, if the why the settlement takes place, the settlement takes place due to expulsion of pore water pressure, or the water void, or the void present in that void get removed. But we have read in the consolidation as well that the uh, give a minute. Okay, so in this case, Okay. Sorry. So in this case, if the pervious layer is in one direction only, so the expulsion of pore water pressure, expulsion of water takes place from this direction only. So over here, the thickness of layer become h. But in the same case, if if okay, if but in this case, if the things gets changed in this manner that this both layer become pervious, that means permeable. In that case, when the load is applied, the water could flow in upward as well, in this direction as well in this direction. Hence, the thickness of that layer become the 1 by 2, what we are discussing over here, right? Now, oh sorry, I doesn't need to draw that, it is already in the next slide. Over here you see that in the first case, the permeable layer is present in the upward as well as downward direction. Hence, the when the load is applied, the expulsion of water present in the clay layer, it takes place in the both direction. Hence, the 2h become h, and in the same way, in the second layer, if the impermeable layer is present in one direction, so it remains h only, not h by 2, or in that case 2h, or in that case h. Right now, okay. Okay, so now you see over here, if one of the soil layer either above or below the consolidating layer is impervious, water will travel in one direction, and the case is known as the one-way drainage, while the length of drainage path remains same, that is the longest path as the water particle need to travel for dissipating pore water pressure. But in the other way, if the pervious layer is present, permeable layer is present both in the upward and downward direction, in that case, the water dissipation takes place from the both directions. However, if for a particular pressure increment applied during the consolidation test, the compression the comparison of the test sample is plotted against the square root time, and the results show that figure in the test. But okay, what I want to show one more important thing is like, before going ahead, I want to mention that if you have observed for the clay layer, for the sand layer, settlement takes place in very less interval of time. Whatever settlement it going to take place in very small time interval. Small time interval, the whatever settlement is takes place is already achieved. Suppose you are constructing some buildings, multi-story building. So, and over there the soil is sand type soils. So the settlement at those locations takes place during the lifespan of that building only. But why? If over there the clay soil is there, that settlement takes place over years, not even in the 2 year, 5 year, 10 year. Maybe it takes 50 year, 100 year, or many more, because in the clay small pores are there, and that settles over the period of time. Now, okay, uh, let me give a 5 minute break. I am not feeling well while speaking. I am feeling too much pain. Give me 5 minute break. After 5 minutes, I will start. Please be remain in the meeting. Thank you for your understanding. welcome back. So, um, today class will go like this only because actually, if it in my hand, I am not to take the class today. But as the schedule is already fact that we have to finish the 12 class in 12 day, so that's why I have to take this. But if it in my hand, I will never take the class today. So, um, and this class will go like this only, and uh, I think that will be little bit help for me if you will cooperate. So we are talking about the compressibility of soil. The curve is seen to consist of the three distinct parts AB, BC, and C. The AB, if you look at this graph, we are discussing about this only, in which road time versus the sample thickness has been plotted. In this, if you have seen the AB point, which is the initial section, AB, then BC, and then CD. So initial compression or the frictional lag, a small but rapid compression sometimes occur at the commencement of the increment and is probably due to the compression of any air present or the reorientation of some of the larger particles in sample. In majority of tests, this effect is absent and point A and B are coincident. Okay, so I am not very keen to discuss these things. I will move to questions later. If we need it, we will discuss this. The basic thing you have understood already. We move to problems. Once the problem are done, we come over there. Okay, so starting with first problem, in which it is asked the Tarjagi one-dimensional consolidation theory, which we are reading over here, assuming E versus P relationship linear. No, E versus log P relation is linear. E versus log E relationship linear, or E versus log P by P naught relationship linear. So we haven't discussed this today, but if you have attended those lectures which has been taught by sir, you could able to answer. So the option number A, that is E versus P relationship of Tarjaki one-dimensional consolidation theory, because it assuming coefficient of compressibility as constant, hence E versus P relationship is linear. Now the second question says the coefficient of consolidation is used for establishing the duration of primary consolidation, estimating the amount of settlement for the load increment, determining the depth to which the soil is stressed when the load are applied on the surface of the soil deposit, determining the pre-consolidation pressure of the soil deposit known to the over-consolidation. So, if you have read this, the option number TB equal to CB into T by H square. If you have remember, we have shown you this correlation. As TB equal to pi over 4 into percentage U by 100 square. Subsequently, this TB is related as as TB equal to CB into T by H square, where where H is the thickness. Okay, so in this it is asked that the coefficient of consolidation is used to establish the duration of the primary consolidation, establishing the amount of settlement of the load increment, determining the depth to which the soil is stressed when the load are applied on the surface of soil deposit, determining the pre-consolidations pressure for soil deposit known to be over-consolidated. So option number A, that is establishing the duration of primary consolidation, is the correct answer. If you read, has been written, and that we it has been written and you understood as well, that TB equal to CV into T by H square, where TB is also equal to, let me write, or these two correlation are used. This relation is used when percentage U is less than 100%, and this relation is used when percentage U is greater than 60%, that is 60 to 100%, more than 60 but equal to or less than 100, and that is for percentage U less than 60%, at which the value is 0.287 or 283, as I could recall. I don't remember 283. I Okay, so this question is clear. Now next the true and possible question, in which it is asked that the 50% of the consolidation at site subjected to the stress level of 200 kPa occurred in 2 months. If the site has been um, loaded to 400 kPa, 50% of the consolidation element would occur in 4 months. So it is clearly the false statement. So the option is not mentioned, so false is the correct answer for this. Why? Let me write also, because I think so without explanation. P. If 50% of the consolidation takes place, this means what? 0.196. Okay, so these are the correlation which we use, that 0.196 equal to CB into T by D square. But if we have to achieve the 50% consolidation only, it is not any good thing like if we increase the effect, it will if we have a site has been loaded with 400 kPa, the 50% will take place 4 months, because if we are increasing the stress, how it will takes place more time than the earlier. So that's why it becomes the policy statement. Now the next question say the slope of E log curve for the soil mass gives coefficient of permeability K, coefficient of consolidation CV, coefficient of compression index CC, or coefficient of volume compressibility. So it gives CC, which is delta E by log sigma 2 upon sigma. Okay, now onward I will show the question and write the answer, type the answer, try to speak little more less. So please read the question by yourself. So over here, options are clear. So the correct answer for this is option number B, that accelerate the concentration. How? Let me draw. Let me write. C for clay. Sand is there, sand is there, and in this case, the consolidation settlement takes place quicker because the water will dissipate in the both directions. So the accelerate the consolidation settlement is the correct answer. Now the next question over here. So the stress strain behavior of soil. Now you can see curve 1 and curve 2. Each curve 1 so the sharp turn after reaching the specific axle strain, but in the curve 2 a progressive thing is given. So first curve 2 so the normally consolidated soil. First of all, if you would look over here, so first of all find normally consolidated. So option number C and D could be the potential answer. Now the loose sand and normally consolidated. So the option number C is correct because curve 2. So the dense sand and normally concentrated clay, while the curve 1. So the dense sand, and that's why once it reaches the specific strain value at the desired shear stress value, it will show the sharp turn in the horizontal direction. So option C is the correct answer for this given problem. Now, this is another question in which the time of clay layer to achieve the 90% concentration takes 15 years. Time required to achieve the 90% consolidation is the layer where twice as thick as 3 times more the permeable than the 4 times more compressible. So the first of all, I will write the relation over here and leave it to you for the next 5 minute break in which you solve this problem. Okay. So you know TB equal to CB into T by T square. Um, this one. Use this correlation to I am stopping here for another break. Please try to solve this problem which has been shown on the screen. welcome back. I'm extremely sorry for today class because I could not able to make the class as per your expectation, as per my expectation as well. But let's see how long I could take. Maybe in another half an hour I will end up the class. Okay, so we have this question in which it has been asked that the time of the clay layer to achieve the 90% consolidation takes 15 years. So the time required to achieve time required to achieve 90% consolidation if the layer were twice as thick, 3 times more permeable, and 4 times more compressible would be. So I will clear something over here. So one important thing that Cv equal to K by mv gamma w. This is another correlation. So over here the permeability there mv equal to Av by 1 plus E naught. So permeability is there and compressible for compressible mb is there. Mb is nothing but Av by 1 plus E naught. So through this relation we have calculated. I have already the solution. So let's see. P equal to Cp by d square. T is proportional to d square. T1 by H1 equal to T1 by T2 square. So 15 by T1 equal to H by 2H. So T2 equal to 60. Next question is consolidation in soil is a function of effective stress, does not depend on present stress, is a function of pore water pressure, is a function of total stress. So it is a function of effective stress. Option A is the correct answer. And explanation is also mentioned over here, in which it is said that. So I will share it with you. I will not going to read this. Next, H. Identify the first statement from the fourth statement. The first statement says the consolidation of soil. First statement says the consolidation of soil happened due to change in total stress. Second say when the standard penetration tests are performed in the fine sand below the water table, the dilation correction is applied after the overburden correction is applied. Third say over-consolidated clay will have predominantly cohesive strength as compared to tensional strength. And the final statement says the compaction of soil is due to expulsion of water. So you have understood that the correct answer is option B, which option 1 and 4, because option 4 is correct, in which there is no confusion, because I have discussed today as well that when the pore water pressure get exhausted, specifically when we have discussed the two layer of drainage in which the upper water get expelled out from the upper and lower section both. In that case, expulsion of water takes place in two directions. That's why the concentration takes place at the relatively faster pace. Now, option 4 say compaction of soil is due to the expulsion of water. That is correct. And the option 1 say the consolidation of soil happened due to the change in total stress. So that is the another correct option or the correct answers. Right. Now, the next question over here is the time for the clay layer to achieve the 85% consolidation in 10 years if the layer was a half as thick, 10 times more permeable, and 4 times more compressible, then the time would be required to achieve the same. So, the similar question we have solved little back. So, over here I am again using the same concept, that is dV equal to CV into T by D square. CV equal to K by MV comma W and MV equal to AB by 1 plus C naught. The solution is like this. Over here you see K equal to CV into MV comma W, and we know dV equal to CV into T by H square. But by implementing the relation K equal to CV into MV comma W over here, CV become K by MV comma W, and when we relate it with time, it becomes H1 square into TV by K1 into MV gamma W. So T1 and T2 in now in the first uh, we know the time T1 as 10 years, so we need to calculate T2. When we do the calculation by resolving all these, it comes out to be 1 year. Right. Now, for a double draining clay layer, next question says a 6 meter thick settled by 30 in 3 years under the influence of certain loads. If the final consolidation settlement has been estimated to be 120 if a thin layer of sand having negligible thickness has been introduced at a depth of 1.5 meter. Again, over here you see the a permeable layer is implemented between that layer in order to accelerate the consolidation settlement. So over here you can see that the final concentration settlement of the clear layer will be. So again we use the same correlation which we have discussed, that it is equal to 7 into T by D square, and the solution has been done, which comes out to be 120 So I'm not going to do that, but I am very much hopeful that if you have understood the previous questions, this solution for this is very easy for one and all. Now you see the next question, which is mentioned that at a reclamation site for which the soil strata is shown in the figure over here, a 3 meter thick layer of fill material is laid instantaneously on the top surface if the coefficient of volume compressibility is this. So the consolidation settlement of the clay layer due to the pressing of the fill material will be. So another relation is like that. Delta H equal to H into MV into delta sigma. So it becomes sorry 3 multiplied by so 3 into 21. That is delta sigma. Whatever it comes out to be, that will be our answer. So I think so the thing will be clear. And over here, in the solution is already mentioned over here, which you see. First of all, we have calculated delta sigma. like this, which comes to 63. Now we multiply that with H naught and MP. The value comes out to 0.1386 meter. Mm, mm, mm. Right. Now next question is that if the pressure acting on a footing is 40 kPa, the concentration settlement of the footing will be. So the figure is also mentioned over here, and in solution, first of all, we have calculated the BDS as 1.2 plus 2 into 0.5 into 3, because we have considered a layer at the center at 3 meter. So the dissipation takes place in this manner. So this is right. So two vertical, one horizontal. In that fashion, we have calculated first of all BDS. Subsequently, we calculated the sigma naught. Sigma naught is here over there is 18 into 1 plus 20 minus 9.81 into 3. So that comes out to be this much. This okay, delta sigma is nothing but 40 kp 40 into 1.2 divided by 4.2, because it is a strip footing. If it is a square or rectangular footing, the calculation will be take place in the other order. But in the strip footing, the other dimension is considered as 1. That's why the calculation has been made in this manner, and the value of delta naught, the delta sigma is calculated. That comes out to 11.43. Subsequently, when we are going to calculate the settlement over there, the delta H equal to Cc into H naught by 1 plus C naught into log sigma naught plus delta sigma to form sigma. So when we use those correlations, we come the value comes out to be 31.8. So over here, some mistake is there or whatever, I don't know. But the question and solutions didn't match one another. Now, the next part of the problem says that if, okay, so this is the question I feel. Okay, come to this problem. And last two problem with the question and answer are mismatch during my placement. So leave it in that manner at this point of time. Once I finalize the document for sharing, I will revise it and share the correct copy with you, so that it will be helpful for you in that time of discussions. So we wait that for this point of time. Now, see, the next question says that a 65, a 6 meter thick layer undergo 90% concentration 4 times faster under the two-way drainage as compared to one-way drainage. In an identical clay layer of 15-meter thickness, the two-way drainage will be faster compared to one-way drainage by. Okay, so if it is 4 times faster, so this time it will become uh, 4 times the time required for any degree of concentration and be obtained by Taylor formula T equal to CV. If the CV is the concentration T also remain constant for the same degree of concentration, it will require the same duration, that is the mm, option B, that is the 4 times. Next question is root timing method is used to determine. If you have remembered, we have a graph like this, which root time is there, and something like this, A, B, C, D. Those things are there which we have discussed, but I have left it that I will share with you. You will read by yourself because those are theoretical things. So once you read that, you come to know that root time method is used to determine the TB, that is the option number CB, is the coefficient of permeability of the consolidation. Yes, the next part of the question, which link the question presented and it depends from one another. Over here, the question mentioned that the average effective overburden pressure on the 10-meter thick homogeneous saturated clay layer is 150 kPa. Now, um, the consolidation test on an undisturbed soil sample takes place from clay layer showed that the void ratio decreased from 0.6 to 0.5 by increasing the stress intensity from 100 to 300. So delta sigma is nothing but 200. So the initial void ratio of the clay is asked. So everything is given, G is given, void ratio is given. So you need to calculate first of all the initial void ratio. So you apply the equation CC equal to U1 minus E2 log sigma 2 by sigma 2 is given as 300, sigma 1 is given as 100. When you apply this equation, you know the value of CC. So you could able to calculate the value of E naught corresponding to the value delta sigma of 150, which is the relation of coefficient of consolidation. The next part of the question says, right? So next part of the question says the total consolidation settlement of the clay layer due to the construction of structure imposing an additional stress intensity of 200 kPa. So delta H is nothing but Cc into H naught by 1 plus C naught into log sigma naught plus delta sigma by sigma naught. So now 150 plus 200 becomes the sigma naught plus delta sigma. Sigma naught is 150. And in this fashion, then you calculate this, the value comes out to be 0.493. That is nothing but 0.53. Next question is again 19 and 20, which is also a linked question related to one another. Again, over here, if you see, the question says that the ground condition at the site we are shown in the figure. The water table at the site, which was initially at the depth of 5 meters below the ground level, got permanently lowered at depth of 15 meters below the ground surface. The level due to pumping of water assumed flowing data, unit weight of water as 10, and other data also mentioned away. So what will be change in the effective stress in kilonewton meter per meter square at the mid depth of the clay layer due to the lowering of water table. So if you remember, due to lowering of water table, there will be no change if it is in submerged condition. So okay, it's not in the submerged condition, no ground level is there. So we have made the calculations, and the calculations suggest that the delta sigma comes out to be 80 kilometer per meter square. How? Well, first of all, we have calculated sigma CC at edge center, and then there's sigma 1 edge 265. Afterwards, we have calculated sigma CC and delta sigma dash edge 345. And we have calculated the difference between the two. It comes out to be 80 kilometer per meter square. So option number C is the correct answer for the given problem. Next is this, in which option B is correct answer, because the second part of the problem say what is the compression of the clay layer in mm due to the lowering of water table. So the due to lowering of water table, delta sigma gets changed by 80. So we have used that only, and we have used another correlation because we doesn't know the value of coefficient of compression or compressibility index. So delta H comes out to be H naught into MB into delta sigma, and that comes out to be 100 mm. Now, next question say, is saturated clay stratum training both at the top and bottom under about 50% facilitation here under the applied load with the additional training we have presented at the middle placed at the 50% of the constellation will take place. So if you remember it takes 1 by 4 time, that is 16. If it is 16, it takes place in 4 years only. But how the calculation has been made, let me show you. So first of all, we use the same correlation as T equal to C into T by D square. Over here, T proportional to D square and T1 by T2 equal to D1 by D2 square. We know that T1 by 2 is 16, we need to calculate the value of T2. And T1 H and T2 is H by 2. So we have calculated T2H for here. Now, subsequently, second, uh, next question, it has been asked, a saturated undisturbed sample from a clay starter has moisture content of 22.22% and a specific weight of 2.7, achieving gamma W equal to 10 kN per meter cube. The void ratio and the saturated unit weight of the clay respectively are. So, then this is the basic question from the soil mechanics, in which the moisture content both W and G, everything is given, gamma W is given. So we have to calculate the void ratio and saturated unit weight. So use this relation, use this relation. Use the correlation and value of void ratio comes out to 0.6 and saturated unit weight is 20.65. Next question asked, using the property of clay layer and derived from the above question, the consolidation settlement of the same clay layer under the square footing neglecting itself with the additional data as shown in the figure below, assume the stress distribution as 1 horizontal to vertical from the edge of the footing and gamma W equal to 10 each. So you need to calculate that only. 1 horizontal to vertical, that means shown in the figure. Now, when we have calculated this first of all, we use the relation I delta is equal to CC into H naught by 1 plus C naught log sigma plus delta sigma. And first of all, we have calculated the that length at the center of this layer and this section from below over here. And we have calculated the value of delta sigma, and then delta H has been calculated. That comes out to 61.67. Next, next question is E versus log P curve shown in the figure is representative of normally concentrated clay, over concentrated clay, or under concentrated clay, or normally concentrated clay and sand. So if you remember, it is over concentrated because when the graph move like this or between E and log P, if so the over concentrated stage, then so often be the correct answer. Next question is asked about that. Identical surcharges are placed at the ground surface X and Y. If the soil conditions are shown alongside the water table at the ground surface, the silty clay layer X and Y are identical. The thin sand layer Y is continuous and free drainage with very large discharge capacity. Primary concentration at X is estimated to complete 36 months. What would be the time required for completion of primary concentration? So again, this is again T is proportional to D square. So T1 by T2 equal to D1 square by D2 square. In that fashion, when you calculate, the value comes out to be 9. Over here, you see, we have calculated the 9 months is the correct answer. Next question is a layer of normally concentrated saturated silty clay of 1 meter thickness is subjected to one dimensional concentration under the pressure increment of 20 kPa. The property of soil are specific gravity 2.77, natural moisture content 55%, compression index 2.45, decompression index. So primary concentration we have to calculate. So that has been calculated over here for the difference. So please look at this. Next question is about the following data is given in the laboratory sample. Sigma naught dash is this. Everything is mentioned. We have to calculate the MB. MB equal to AB by 1 plus E. AB equal to delta E by delta sigma. Delta is E by delta sigma. We have calculated multiplied by 1 by 1 plus E naught we have did, and that value comes out to 7.619 minus 4. So the answer to be written is 7.619 to the power minus 4 is already mentioned over there. Now the next question is this, which we have need to calculate the expected settlement. So in this fashion we have calculated, and subsequent questions are also mentioned over here and their solutions. So okay, am I audible, Rian? Hello.
Yes, sir. Yes, sir. Yes, sir.
Okay, so I think so. Up to this, I will leave up to this only. I will sum up the session over here only. And whatever discussion we have made, I have not made discussion up to that standard which I want to. So please thank. Uh, I will suggest that I will discuss this thing again in the next class. Maybe I will take one extra class which is offered to me at the end of the sessions. So I will cover these things. For today class, I will remain up to this only, and I will close the today's sessions. Um, I will request you to join in the next session on the next Saturday, because I'm not feeling comfortable to take class any forward. So it will be okay na if I will end the session over here only.
Yes, sir. Yes, sir.
Okay, so thank you for joining. See you in the next class.
Get well soon, sir.
Okay, thank you. Thank you.